Hi guys, as you do lecture in class hour, I upload this video for the new worksheet. This is about probability. If you have any question from this worksheet or the previous one, you can send me email or you can visit me on Friday between 11 a.m. and 1 p.m. All right, so let's start with the first one. We will compute the probability that a 5-card poker hand contains at least one ace. Now, in how many ways we can select these 5 cards from this deck? A deck has 52 cards. You should know that. So how many ways we can choose these 5 cards? It's given by this combination, right? 52 choose 5. So what do we want to compute? We want to find the probability that a 5-card poker hand contains at least one ace. So if we can find first this probability, the probability of hands that does not contain any ace, and if we subtract it from 1, we will compute, we will find this probability, right? So we will first find this probability. So the probability of hands that does not contain any ace is this. So we have 48 choose 5, right? This is not the probability. This is the number of hands that does not contain any ace. So 48, why do we have 48 here? We subtract the aces, okay? We have no right to choose ace. So among these 5 cards, there will be no ace, so we cannot choose them. So from this 52, we subtract these 4 aces. In a deck, we have that many aces. So we will choose 5 cards from this many cards. So this is the number of hands that does not contain ace. Okay, now what's the probability of hands that has at least one ace? So we were subtracting this this probability from 1, so we have 1 there minus the probability of this. So we found the number of hands containing no ace, which is this. And the probability of that is over the whole outcomes, the number of all events, which is this, right? So we have here this one. Now we just simplify them and get the result. It's not that important. You already know that. Okay, the important part is to compute first this, then subtract it from 1. Okay, the second question. Now we will compute the probability again that a die never comes up an even number when it's rolled 6 times. So the possible outcomes for a die, for when we roll a die, we will have either 1 or 2 or 3 till 6, right? Now when we roll it 6 times, we will have 6 to the 6 many possible outcomes, right? Now we want to get an odd number on the die, okay? We want to find the probability that a die never comes up an even number, okay? So there are 3 even number and 3 odd numbers in here. So the possible outcomes that we have 3 odd numbers when we roll that die 6 times, we will have 3 to the 6 many possible outcomes, right? And each time, in each roll, we will have either 1 or 3 or 5. So in each roll, we have 6 possible outcomes. So when we roll it 6 times, we will get 3 to the 6. Now, what's the probability? So here we have 3 to the 6, the events we want, the number of the events we want, which is this. And the possible, all possible outcomes is here in the denominator, which is 6 to the 6. So we have that. Now let's read it from here. Now we we have a wheel with 38 numbers on it, okay? So we rotate it, we rotate that wheel. So on this wheel, we have 18 many red numbers and 18 many black numbers, okay? And there are two other numbers which has no color on them. One of them is 0 and the other one is 0, 0, okay? Now we assume that the probability that when the wheel is spun, when we rotate the wheel, it lands on any particular number is so the probability of getting any number on the wheel is 1/38. Okay, so they are likely. The probability of all of them appearing once is the same. Okay. Now, what's the probability that the wheel lands on a red number? We have 18 many number, right? 18 many red numbers. So we have here the desired outcomes. The number of desired outcomes is 18. And in the denominator, we will write all possible outcomes, which is 38. So we have this. Now, what's the probability that the wheel lands on a black number twice in a row? Now, first we will have 18/38, right? Because we have 18 black numbers, and we roll it again. So in the second part, we're not done yet, so we will multiply it by this. In the second, we can have the same black number. We don't care about it, so we will have again possible 18 possible outcomes. So we will have this. So it's 18/38 squared. Now, what's the probability that the wheel lands on 0 or 0, 0? So first compute this one's probability, then this one, then add them. Okay. So what's the probability of having 0 on the wheel? It's 1/38, right? And this one again, it's 1/38. There is one many 0 on that wheel, right? So we have this 2/38, which gives 1/19. Now, what's the probability that in 5 spins, the wheel never lands on either 0 or 0, 0? So now we will spin that 5 times, but let's compute first the one of them. Okay, then we will take the 5th power of that, right? Now we want it never comes. We want that 0 or 0, 0 never come, right? So in the first spinning, we have again 38 many possible outcomes, right? So either we can have this many number, 18 many red number, or 18 many black numbers. Okay, we don't want 0 or 0, 0. So we will have 36 many possible outcome in the numerator. We will have 36, right? Either the red numbers or the black ones. Neither 0 nor 0, 0. Okay, this one was the first spinning of that wheel. We will do that 5 times, so we will have this, right? Okay. Now we have a pair of dice. We assume that the probability that a 4 appears on the first die is 2/7. So in the first die, let's write it here. So we have a pair of dice. So if we have, so we will have these pairs, right? When we roll that die, so you will have such outcomes. So if we have in the first 4, the probability of that appearing in the first die is 2/7. And if we have in the second, it's given here, In the second, if we have 3, the probability of that is 2/7 again. And the other outcomes have probability 1/7. Now we want to roll that dice, okay, the 2 dice. We will roll them, and we want to have so at the end we will have 2 numbers. We want the sum of these 2 numbers to be 7, and we will compute that probability. Now, what are the possible outcomes? So either we can have first 1, then 6, or first 6, then 1, or 2, 5, 5, 2, right? The sum of them is 7. All of them is 7. So the possible outcomes are here. The probability of this, so first having 1 in the first appearance, the probability of that is 1/7, as in here. And the probability of that, again, 1/7. So we have the probability 1/49 for this die. Okay. Now, this one, this, and these, they all have the same probabilities. So ignore this. This is equal to P of 3, 4. Okay. Now these are all have the same probability. The only outcome having different probability is this, because the first one have the probability 2/7 and the second one again 2/7. So we have 4/49. The probability of having this pair is this 4/49. Now what do we have? So we want to find the probability of having 7 as the sum of these dice. So we need to add them, right? We need to find the sum of these probabilities. So we have this. This is 4/49. The other ones are 1/49. So we have this. Now, let's read it from here. So what's the conditional probability that a randomly generated bit string of length 4 contains at least 2 consecutive zeros? And here we assume that the first bit is, first digit of that bit string is 1, okay? We assume also that the probabilities of having 0 or 1 are the same, okay? So, okay. Now, what's the conditional probability? If we say, so let A be the event that a randomly generated bit string has 1 in the first digit. So this is the assumption. This is the condition we want here. So we have this A there. Now B, and let B be the event that the generated string has 2 consecutive zeros, right? So here we have B. Now, what's the probability of this this condition, this event? It's the probability of A intersection B over the probability of A. Okay, so what's the probability of A? A is the event where we have bit strings generated, the randomly generated bit strings having 1 in the beginning, in the first digit. So we have 2 possible outcomes for each of these digits. So what do we have? We have 2 possible outcomes for each of them. So we have 2 to the 3, the desired outcomes, possible desired outcomes. And what do we have here? So in how many ways we can generate this bit string of length 4? It's 2 to the 4, right? So we have this. This is P of A. Now, what's the probability of A intersection B? There we know that the first digit is 1, right? And the other ones may either 0 or 1, right? But we want them to satisfy this B, the event B. So what's that? Having 2 consecutive zeros. So we cannot, for example, have such bit string. So this A intersection B does not contain this one, this bit string. So what are the possible outcomes? They are these ones. So we just we just try how many possible outcomes are there to find that. So we have 3 possible such bit strings. Thus we have 3 over 2 to the 4. Why 2 to the 4? We have how many ways we can generate that bit strings of length 4? It's 2 to the 4. So we have this in the numerator. Okay, thus if we simplify them, we simplify these ones, we will have 3 over 8. Now 6, we will find the probability that a family with 5 children that does not have any boy. Okay, here we will consider the sexes of children are independent. Okay, and the first one says that a boy and a girl are equally likely. So we have 2 genders here, right? So we can have either a boy or a girl. So each of the probability of having a boy is 1 over 2, and the probability of having a girl again is 1 over 2, as they are likely, equally likely. So what's the probability of that family have 5 children and none of them is a boy? So all of them should be a girl, and the probability of having a girl is 1 over 2, and they have 5 children, so we have this. Now the probability of a boy having a boy is 0,51. So the probability of having a girl, as they don't have any boy, we need to complete that. What do we have? We have 1 minus 0,51, which will give us this 49. Okay, so this is the probability of having a girl. So as again, they have 5 girls, so we have this probability. Okay, that was easy. Now we will select a subset of this set S, which contains these numbers. Okay, it has 99 many numbers in it, 99 elements. We will select that X randomly and uniformly. Uniformly means here selecting a set, selecting any set has the same probability. Okay. Okay, now what's the probability that X has an even number of elements? Now look at here. We know S has 99 many elements. Now what's the number of subsets of S? It's this, right? 2 to the 99. How do we compute it? Why it's equal to that? So selecting a subset of S having no elements is this 99 choose 0, which is 1. So it represents the empty set, right? Now having selecting a subset of S containing only 1 element is this. It's given by the number of those subsets given by this, right? 99 choose 1. Again, similarly, we compute all of them as S has 99 many elements. We're done here, right? We add them and we're done here. Now, this is the number of subsets of S. Now, the number of subsets of S, again, having even number of elements is this. So either that subset has no elements, or 2 elements, or 4, or 6, till 98, right? But we know, on the other hand, that 99 choose n is equal to 99 choose 99 minus n, right? They are equal for any n. So you can now see that this 99 choose 0 is equal to, so this is equal to 99 choose 99. right? They both equal to 1. Now 99 choose 1 is equal to 99 choose 98. Okay, right? The sum of these ones gives us the 99, the number of the elements of S. So they are the same. Okay. So similarly, we will have 99 choose 2 will be equal to this one. Okay. So as you can guess now, the number of these combinations is half of this number, right? So if we divide it by 2, we will get the number of these sets, these combinations, which is 2 to the 98. So this gives us the number of subsets of S consisting of an even number of elements. Okay, and the number of the subsets consisting of an odd number of elements is the same with this number. They are the same, as you see here. So in the numerator, we need to have these outcomes. We need to write this one. Okay, the number of subsets of S consistent of an even number of elements. Okay, so the total outcome is this. The event is selecting a subset from here. It's 2 to the 99 choose 1, so it will be the same. Thus, we simplify them and it's 1 over 2. Right? Okay, that was the last question. If you have any question, you can send me an email or you can visit me on Friday, as I said before. And good luck with the exam.